Now, when we know how crucial performance is for SQL servers, it's definitely a good idea to invest into a proper monitoring software that is able to monitor all the SQL servers, the instances, the databases, so you're able to keep your service levels up and have the best possible uptime. So now let's talk about different monitoring methods. We have reactive monitoring methods, and then we have proactive monitoring methods. So what these reactive monitoring methods basically mean? It answers the question, where do we have potential performance issues at the moment? So it's actually constant firefighting. It means like, for example, if I set 80% threshold level for peaking CPU utilization on certain particular server for a 5-minute interval, and when this 80% limit is exceeded, I get an instant alert. Then I know, okay, there is something wrong with my CPU. Maybe it's related to some bad code issue or something, and then I'm able to drill down to see the root cause of the problem, see the other performance counters, see the weight stats, go into plan cache, drill down to weight types of the SQL queries, and so on. Okay, but what about proactive monitoring? What does that mean? Well, it answers the question, where will we have potential performance issues in the future? So how do we can answer such question? For that, we need actually applied mathematics. We can use, for example, statistical analysis like linear regression, exponential curve, and things like that to recognize how the performance counters are evolving, and depending on the volatility of the performance counter, having different length of, for example, regressions to analyze what is the average momentum of that particular performance counter, when it will hit the ceiling. For example, when the threshold level is being hit, is it in next 5 minutes, next 2 days, next 2 hours, and so on. And we can go even much more further with mathematics with this. We can, for example, use anomaly detection. We can use pattern-oriented analysis. Pattern-oriented analysis applied with machine learning. Then we are able to say what is the probability of certain behavioral pattern that cannot be seen on bare eye from the data that we are surveilling. What is the probability to hit that certain threshold level of alert, and when would it occur? So in this way, we can react the problem before it even occurs, and therefore we can get even better service levels and higher uptime than with just ordinary reactive monitoring.